On behalf of the California Institute for Energy and the Environment, which is led by Carl Blumstein, and myself, the CITRIS activity, we're very pleased today to welcome Chris from the PG&E activity. The fact that the room is so full, despite the fact that many graduate students are insanely trying to get their theses read and signed, is a testament to how important this topic is. And I know it's going to be a terrific presentation. This is a very important day for us. Chris has been logged into the White House this morning as these regulations for the smart grid are being rolled out. And I think Carl and I would say that we're delighted to know that PG&E, because of many years of creativity, is leading many of the elements of that work. So, Carl, do you want to say a few words on behalf of CIE?
I can't resist the microphone, Paul, but again, just to welcome PG&E and to say thank you, Chris, for taking the time to be with us today.
Good. And so these i4Energy seminars are gathering momentum, and as Gaiman was just recently saying, we quite expect the next one to be in the new building over in the Satarja Hall, which is the CITRIS building. So for now, let me, as usual, warmly welcome Chris by a round of applause, and we have our friends out of the various campuses too. So.
Thank you. Thank you. So first I'll say I know it's finals week, so if we run long and if anybody has to excuse themselves to make a test, I won't be offended, so you can just head out if you need to. Number two, within reason, I don't mind. This is such a small, intimate forum that if there's someone really has a burning question or a point they want to make through the discussion, just go ahead and raise your hand. And as long as we don't get too stuck on some topic, I'll be happy to take questions. So I think before I get into the presentation, there was a meeting in the White House this morning where Secretary Locke and Chu invited industry execs, so it was CEO. I was actually on the phone with someone that was there, so after the fact. But there was a meeting where Secretary Locke and Chu, the Secretary of Energy and Commerce, and George Arnold, who is the head of running the standardization effort in NIST, who has been previously from AT&T and Bell Labs and president of IEEE SA, they basically just validated his position and said, hey, we're going to do this, we're going to move it fast, this is our guy, we're going to do it, and we really want everybody to get behind it. And I'll talk a little bit more about that actually in the presentation, but I think it's really quite significant that level of focus, it's at the cabinet level and at our president's level, the imperative and the drive to get a smart grid completed and to drive energy efficiency and other benefits to the United States. So today I'm going to just a little brief on what PG&E is. I'm going to go through kind of what I define or what we define a smart grid as. Why is it important? And then we'll get into the meat of standards, and then a little bit of what are we doing at PG&E around creating a smart grid. So this map on the left is actually a heat map of our meter density. So you can see we have a large area. I think 85% of our territory represents only 10% of our meters. So we have this very large challenge of covering this large territory to provide service to our customers. We're 70,000 square miles, 20,000 employees. We're a publicly traded regulated utility. 6.8 megawatts of generation, which is actually small relative to other utilities of our size. I think through deregulation we actually lost a lot of our generation, which means we have to actually go procure that energy from other sources and run it over transmission lines. We have 18,000 miles of transmission, 120,000 miles of distribution lines, a fair amount of gas. And I think this last fact is actually one that kind of highlights where utilities are going. I think in the past utilities would deploy very traditional technology. Well, we're deploying greater than 7,000 IPv6 wireless mesh meters per day. So every meter that we're deploying is a IPv6 router. It has configuration, it has application space, it's a highly complex device. I think we peaked one day at 12,000 So by 2011, all 5 million of our meters will be IPv6 meshed nodes. So what is a smart grid? This is a definition from the CPUC OIR. And in the simplest terms, it's really the integration of power delivery and communications technology into a stable system. And I think that's a really key point to make. We're networking all these things. We're putting control loops and closed loop cycles within this architecture. So all of a sudden you have all sorts of stability risks. So it's very important as we go down this process that we make sure the system remains stable, that we don't have that we have multiple means to mitigate such modes in the system, and continue to provide a reliable 4/9 service to our customers. So we'll go through a little picture here. So these are the traditional elements of a utility distribution system. You have the transmission operator, the distribution operator, the load serving entity, and a substation, and those lines are all connected. And they deliver power to different classes of customers. You've got a residential customer here, which is somewhere below 20 kilowatts. You've got 20 to 200 kilowatts in the commercial, and then you get very large customers, which are greater than 200 kilowatts. What we are adding, and this is, I would say, somewhere from 70–80% of the smart grid, is just simply networking all of this together. So how do we network all of these elements together in a seamless, reliable, robust way? Once you get it networked, or as we go down that networking path, you can start putting out distributed computing elements. So there's going to be so much information flowing back from all of these different entities that it will be almost impossible. I believe it actually will be impossible to centralize all this information. So much like the internet makes decisions locally and decides how it routes traffic, in a similar way, the smart grid will have to make local decisions on how it executes commands to, let's say, maximize energy efficiency or maximize reliability. A good example would be if you have a whole bunch of vehicles that come on at one time on one transformer or within a window. A vehicle can represent 1 to 2 additional air conditioning loads. And most of our grid, in fact, our grid is designed for 1 air conditioner per home. So you can quickly kind of conclude that if I have multiple electric vehicles plugging in, I can exceed the load of that transformer and cause a reliability problem. Well, if we have sensors and communication elements on all those devices and a local processing engine, you could actually make a decision locally, send a command to that vehicle to say, hey, don't charge now, wait. Or we could throw a disconnect on the house to preclude, let's say, a catastrophic failure. And all of these things have to be worked out, but trying to pull all that information from all of the customers back to a centralized location really wouldn't be possible. And finally, the whole grid has to evolve to support two-way energy flow, not just two-way information, but two-way energy flow, because as time evolves, there will be a larger number of distributed energy resources, photovoltaics. There's discussions around vehicles being used as storage elements. There is a lot of research and development in storage right now. So energy will also become two-way. And this is an example of a lot of those different applications that will get, microgrid type applications, vehicles being used as storage, other distributed resources being used as storage, and then large-scale storage tied into the transmission systems as well. This is a blow-up of some of the things that are going to be happening around the consumer side, and I think the work, one of the things that's falling out of the work in DC that NIST is driving is a common framework. So prior to this coming session, you could go Google and find a dozen different views of what the smart grid looked like. What was the framework? How was it broken into domains? What are the interfaces? One of the first things that's going to come out is a common framework. So we're going to get the whole country looking at the interfaces and the segmentation of the domains of the smart grid in the same way. And the consumer domain is probably one of the most heated topics right now, just because there's so many interfaces. It drives a commercial market. There's so many different ideas of the different type of products and services that companies want to they want to go try to develop in this area. So I mean, Google's got this power meter thing. Cisco's starting to get engaged in the market. You've got Microsoft, you've got Oracle, you've got all these traditionally non-utility from the sense of customer interface products working to get engaged in this market. So all of these interfaces and the standardization around how do you deal with plug-in vehicles and standardizing that interface. How do you deal with load management of air conditioners or the AMI meter systems or the distributed solar on the roof. All of these will be defined with a common standardized interoperable interface. And then you've got these heated discussions in industry. On one side, you've got those that are very pure, looking at what's the best academic or best technical solution. And on the other side, you have, let's say, a lot of vendors that have products that they're already engaged in or in the market, and they really want their solution to go. So it's those of you that are involved in industry standards, it's kind of the classic tension between those two, and it's happening across all these fronts right now. This was in my opening comment. The complete system must be scalable, and this is just a drill down of kind of the way I think of things. When I step back and I say, where do we want to be, let's say 20 years from now? What is really driving us? What is kind of a penultimate target around the smart grid? And I really see it as networking all of these elements, and from the ISO's point of view, which controls the supply and demand equation, either through the utility or it could actually go out through another means. An ability to have a demand meter, or to have a meter that could instantaneously tell you exactly how much demand or negative generation you had in the system, and you could turn a knob to adjust that and affect that in a distributed way, in the most cost-effective way across this widely distributed set of elements, which is the smart grid. Now, we'll never achieve that, right? That's an ideal solution. But the closer we can get to that type of control, the more efficient we can be at managing our energy and our resources. For instance, the ISO right now, we run with 15% spinning reserve or excess energy available to turn on when we need it. That is sitting there being used at any time in case we need it, let's say, due to variability in wind or some other load. If we had a much more accurate picture of what was happening across our system with the relative load we could affect, you could procure less energy and therefore be more efficient and therefore spend less money. So why implement a smart grid now? So I came to PG&E a year and a half ago, and my background is all high tech. It's all startups. I did some of the early AMR systems, and I've circled the utilities, but I've never been in a utility. So one of the first questions I asked is, well, why is this important? Why is there this all of this energy being spent on smart grid and energy imperative? Well, this is the NERC 2006 long-term reliability assessment report, and what it says is that somewhere around 2015, in the summer, this is in the western states, our peak available energy margin drops below zero. Well, we're not going to run out of energy, but you can imagine the price would rise. There could be all sorts of effects. So this progressively increasing trend towards lack of excess margin at peak has really driven all of these initiatives. And the problem is there's no good supply side solution. You can't go build enough generation or build enough transmission lines to continue to supply the amount of energy and the increasing demand that we as a nation are driving. And a lot of that is just not in my backyard, right? You don't want a nuclear plant in your backyard, or I don't want those transmission lines going over my kid's school. So it gets increasingly hard to actually put the things in place we need to evolve the system. So what that leaves us is a dynamic distributed demand side solution. So can you network all these together? Can you take advantage of all these little bits and pieces of energy efficiency that we can manage from all of the different homes and businesses and add them up to equal what instead we would have to build as generation? And I think what's really interesting here is this was a survey that was taken, I forget when this was, I think early this decade. But there's a tremendous amount of energy that is used in, I mean, everybody knows, I think, that air conditioning is the major contributor at peak. But you also look at some of these other numbers. There's cooking, there's drying, there's pools, and there's refrigeration. If you can make these devices smart, if you can make consumers aware that the price is high, there's a lot of indication that you can actually change these. So there's a lot of opportunity here through systems and control elements and networking to reduce the amount of energy that we use. This is another interesting chart. This is a EPRI did a study to show what might be a hypothetical solution to reduce greenhouse gases from where they are today to where they were in 1990. So that gets to this target over here. And this particular assessment shows efficiency being 9% of that equation, and it shows vehicles and other distributed energy resources being 5% of that. So a big piece of greenhouse gas reduction is tied to actually networking and putting together a smart grid. Okay, so why now, right? So you can do all these studies and have these reports. Well, someone's got to start paying the bills, or someone's got to start driving this to actually happen, to drive business to see some economic need to do it. In December of 2007, the Energy Information and Security Act was made into law. Within that legislation, there's a section on SmartGrid. It defines NIST as the entity to build a consensus set of standards for interoperability. It regulates. It defines that the DOE shall create a rulemaking based on that consensus set of standards to mandate interoperability for the smart grid. And then with the recent ARRA funding, NIST was given $10 million to actually do this work. So they were mandated, and now they've got money. And that is actually quite a hot topic now and very active. In some of the later slides, I'll get into exactly what's happening, fairly real time right now. So our California Public Utility Commission has also taken steps to address it. They're quite active in the process as well. And I mentioned NIST is moving forward, and the stimulus package is driving this. So why is this so important? So some people that have been in standards and have worked there through their careers, I think, really understand it. It's very intuitive. But there's a lot of individuals and a lot in the utility industry that really haven't been involved in standards. So I think these are just some general comments that are good to get out in this discussion. So number one, it's a big challenge just explaining this to people that aren't engaged or don't understand it. But from my perspective, whose whole career has been working in new technologies and standards, the scale, the priority, and the energy of this far exceeds anything I have ever seen before. And I've been in some pretty moving, large-scale new technology developments. But the fact that this spans all of power engineering, almost all of telecommunications engineering, just that vast scope of technical area, and the amount of dollars that are going to be spent, it's going to be tens of billions of dollars over the next decades in this area. So it brings people forward. It drives work in these bodies. Security standardization, and so the second bullet here, distributed energy resources, and I lump load in there as well. Load is megawatts, so I just think of it as another type of negative generation. Security across everything is probably the number one topic in all the discussions right now. The regulation will force security. Right now, utilities are subject to audits and regulations on the transmission side for certain aspects of the business. But the discussions right now happening are, it's not if the regulation and security constraints are going to go all the way down to the customer side, but who's going to regulate it and when's it going to happen. So it will happen. So you'll see defined standards and security all the way down to the home, which will force a set of standards and force interoperability. Yeah.
Can you define security in this one?
So security covers all aspects. So cybersecurity would be one way to define it. So the communications link needs to be secure, but the facilities also need to be secure. The process of those that, let's say, have the keys have to be secure. How you break down the elements of control. So no one button should be able to shed load on the entire network. You probably have multiple barriers and multiple elements that have to happen. So when I say security here, I mean in general across all aspects. Not just the communication protocol, for instance. Utilities are highly engaged in this process. I actually chair a group in UCA called Open SmartGrid, which we have 10 utilities representing 27% of the U.S. meters. And those 10 utilities are the 10 that are highly active in either deploying these technologies or labs or working in the standards organizations. And we've done quite a bit already to affect documents that have driven standards, and I'll talk a little bit about that later. And we're also aligning. There's kind of a group, EEI, UTC, EPRI, NIST, and there's others, but there's definitely a coalescence of kind of the key players in industry all aligning on common architectures and solutions. And then I run into this a lot too, right? Sometimes SmartGrid is, that's just the transmission and distribution system. But in my mind, it's everything. It's analogous to the internet, and it'll never get done, right? You can't. Another comment is sometimes, where do I go buy my SmartGrid? Or I'll have some consulting agency come and say, hey, let's go in a retreat for 2 weeks, and we'll go design your SmartGrid for you. Well, I don't think you can ever design a SmartGrid. I think of it as an evolution of power engineering and communication technologies, adding features over time that continues to evolve. And the standards will continue to evolve, and the features, everything it'll be like the internet today. I almost think that I look back to where I was at 1990, and if you could look forward and see the internet where it is today, I kind of think we're 20 years from now or 15 years from now, we'll look back and it'll be something similar to that. We're at the very beginning of something that is going to be analogous to the internet, but around a smart grid or the integration of power engineering and communication engineering. And then, a lot of discussions, there were discussions, I don't know, a year ago or even less. Well, why can't you just get a few smart people in the room and define what it is, and that'll be it, and we'll all be good. Well, you quickly come to the, those that have been in the space know that unless you go through a consensus process, unless you develop open standards, you can't possibly get everybody to engage. You can't drive an interoperability program. So open standards are an absolute requirement for interoperability. I talked about how this will be mandated and eventually regulated. Without open standards, you can't achieve a smart grid. But more importantly, without a compliance program, without a way to actually certify devices that they actually comply with the standards and interoperate with each other, you can't have a smart grid either. If you just have things that are defined as open standards, Company A and Company B and Company C will all implement their devices a little differently. They won't interoperate, and you might as well have proprietary solutions. Yes, sir?
Suppose that this grid works perfectly, and it's already done. It's going to be sending price signals back to the consumers. Why can't we do that today, system as it is, the end of the bill at the end of the month?
The question, so I'll repeat the question. So the gentleman asked, with the system the way it is today, why can't we send prices out to the consumer? Well, I think the system doesn't exist to do that today.
Okay, but assume that it did. And the bill at the end of the month is a price that you're paying for your consumption.
Correct.
Why isn't that enough of a signal?
It's a complex equation. You can't just send the signal and take action. Security is an issue. How do you guarantee security? Right. For instance, that's one example. Right. How do you define that vendor A and vendor B will all create the same communication protocols or systems to communicate to each other? So you simply can't just say, what if it exists today? Right. You have to do the work. This is not easy. Right. You can't just say, what if it exists? Would that signal be all that is necessary? Because it's a highly complex design problem, and you have to do the work to get something that's reliable, that's scalable, and that's secure, right? So, I mean, that was a fairly open-ended question, but I hope hopefully that answered it. Okay. So the industry is highly engaged. I see an ever-increasing number of utility rate cases depending on these emerging standards. So utilities are actually becoming high-tech companies and will have to become high-tech companies to execute on these, and I see it across industry. The only way to really execute efficiently is to have technical depth, to be involved in these standards. And then the more and more that these systems depend on emerging technologies, the only place that they're actually implemented for real at end-to-end functionality is within a utility. And I think, as anybody knows, any of you that have ever worked on emerging technologies, unless you implement the exact thing you're going to deploy, you'll always forget something. You'll miss something. So the idea is to implement these things at small scale in pilots, understand the things that are missed, feed that back into the process, both in standards and with the partners that we're developing it in industry. And then by the time you scale, you've actually have a fairly reliable solution. I'll talk a little bit about some of the key principles within a standard strategy. So openness is a pretty vague term, right? And I don't think there is a binary definition of what is an open standards and what isn't. It's really a continuum. And I kind of weigh it with four sets of criteria. One is, if I look at a standard, how adopted is that technology? How many places can you go buy it? How many different entities are deploying it? How easily can I get it? Do I get it from one vendor, or can I get it from 3 or 4 vendors? Can I participate? Can I go to a body and affect the outcome of that standard or the evolution of that standard? And finally, is there open governance in that process? Is there a known voting process? Is it fair? Is it defined such that even if I don't have my view, I know what the process is, so I'll accept it? And I think this is really important, that if we go through this development of smart grid standards and we don't follow this path, I don't think we'll be successful. And fortunately, those at NIST and those involved understand this. And the tension right now is trying to balance that knowledge with the urgency to accelerate this process. Separation of duties. You don't just go to standards organizations to develop standards. You have industry users groups and you have industry alliances, and all of those have a place in the process. One develops the standards, the other typically develops the requirements, and the industry alliance typically is responsible for the certification of, let's say, a suite of standards defined by an industry users group that meets a business need for them. Generational compliance. You have to make sure that what you have in the first generation of the standard actually can live going forward with other standards. So we don't want to strand standards and have non-backwards compatible issues. And then finally, last, but maybe one of the most important principles in what we develop is that we have loose coupling between the layers. So, for instance, if there's any technology that's trying to do addressing in the application layer, that's a really bad thing. You want to be able to evolve the solution over time. So, for instance, in the home area network today, 15.4 and let's say Wi-Fi maybe choices here. We're evolving. Roll is in IETF is developing some middle layers, and we're aligning the Zigbee work with that. And then there's a common information models that are defining the interfaces to the application in IEC. That's a nice architecture because you can pull pieces out over time as technologies evolve or new applications grow. And then I think some of the benefits of open standards. This is a list, but 50% savings in the integration costs over time. You avoid reinventing the wheel. We build on what's been done in the past. You really prevent the single vendor lock-in, which vendors like that because they have higher margins. But the flip side is that you have a much larger market share by driving open standards. You reduce maintenance and training costs, overall development costs. I can actually go hire people, right? I can go hire people if we're using IP standards, for instance, and building on it. I can go hire people are readily available, whereas if there was some, let's say, proprietary solution, the only engineers that understand it are the ones that work in the company that developed it.
Could I ask a specific question? I mean, would that mean, for example, that PG&E is going to have to go through and change some of the control equipment that's in the substation near my house? I'm trying to get, maybe I'm being too much of a geek, I'm trying to get an idea of one thing that you might have to change to fit into the standards of the interoperability. Maybe you should repeat the question.
That's a really good question. I will repeat it. So the question is by defining interoperable and open standards, what does that do to existing technologies? For instance, we have DNP3. It's a substation technology, right?
I don't know what that is.
It's not a clean layered architecture, right? And what do we do with those systems that exist today in the substation? And how do we migrate over time to, let's say, this definition of an emerging, open, loosely coupled architecture? So that specifically for that one, I think, I mean, this is my opinion, right? This is all going to work out, but I think what we're going to see is kind of IP-based standards, or the evolution of IP-based standards be the transport mechanisms through a lot of these networks.
Okay.
But you can't just define it's going to be IP. IP has to evolve to support those protocols. Day one, you would have a gateway or a translation device in between that would translate to those elements.
From your technology, I see.
Yeah, from what to those and migrate out. And then DNP3 would be a good example that the IETF may open some working groups where you would actually port that protocol over to IP and evolve the protocol to support that specifically, so then it becomes native. And over time, those gateways can move out. So as we fund programs to replace our infrastructure, we would move the old technology further and further out to the edge, and the new technology would migrate out, or we could be flexible as to how we scaled that over time. Yes, sir.
Well, as a matter of fact, 10 years ago, PG&E faced this problem with the fact that they had a lot of different technology out there that couldn't talk, and they had 2 floors at 77 Bill full of programmers that were writing translation codes to have those devices talk to one another. So that was the solution then, and that was, I remember, I was there. That's when we vowed and we joined the program at UCA at that time. To avoid that problem.
Yeah, and we still have a lot of multiple instantiations all the way back to the application layer for different systems, and that's not desirable because it costs extra money, it has reliability and maintenance issues. The idea is over time to migrate to a more common base. We really don't want translation boxes. I want native transport. I want secure native transport across a common set of layers for everything. And we'll probably never get there, but we certainly want to minimize the outliers to the common architecture over time. So now we're getting into the real-time stuff. So this is what's happening. So NIST has been appropriated $10 million to drive this standards, which is quite a bit of money actually to go drive standards. And they've given EPRI an initial contract to go get the first phase of that work done. George Arnold, he was VP of Standards and IP at Bell Labs. He's out of Lucent. He was president in the past of the IEEE Standards Association, as well as chairman of the board of ANSI. I've talked to him. I've watched him talk. I think he's a great leader for this. I mean, he knows what needs to be done, and he's good at shaping and steering the industry. So, I think number one, I think the right guy is there. There's a guy that can do the job there. The flip side is that he and NIST are under extreme pressure to create this roadmap. I mean, it's for someone that comes from a background of developing standards, the time frame to try to get this done seems almost impossible. But we're gonna dive in and help get it done. So, release 1 of this interim roadmap is targeted for May 28th, which is within a couple weeks. And there's been a lot of work going on in the past year on this. We had a 2-day workshop in Washington, D.C. for 28th to the 29th. And in the press release this morning from Secretary Locke and Chu, the actual first set of, I think it's 16 standards that we agreed were kind of the no-brainer baseline came out on that list. And I'm heading on a red-eye tonight to the 2nd day workshop in D.C., which is going to take this to the next step. And I think in this next one, we're going to work on defining a further expansion of the set of standards, but also work on shaping the process that is used to define these. And then, the way I look at it is our job is to help NIST to be successful, right? If we, I think it's the right people, and I think they're doing the right thing given the pressure and the imperative. And if we don't help them to be successful, I think you kind of digress into some type of chaos that isn't good for anybody. So we're basically at PG&E bending over backwards to help them get this job done in any way we can. So this is the list of low-hanging fruit standards, and I see Mary Ann back there smiling at the Open Automated Demand Response, which was an LBNL effort, which we as PG&E worked to some extent with. But I think these are all pretty benign. I don't think there really was much contention in these. I'll point out these Open HAN and Zigbee Home Plug Smart Energy. This is there was a lot of work done in the past year. These requirements were developed for the home area network under UCA, and our utility leadership group has put a lot of energy in helping shape the requirements with Zigbee, an integrated Zigbee home plug solution for home area networking, moving to a layered architecture with IEEE at the lower layers, IETF at the middle layers, and IEC at the upper layers. So I think it's a good example of what we want to see happen across all of these different domains within the smart grid. So where are we? This is simply a slide I've used internally to say, well, where am I putting my resources? Because we don't have as many. We never have enough people to put on standards as you like. So where are we focusing? And this is certainly not a comprehensive list, and certainly anyone that isn't highlighted in green isn't relevant or important. This is just where we're working at PG&E. So we've certainly focused on the NIST and FERC relationship. UCA we're heavily active in, EPRI, EEI, the IEC bodies and the Common Information Model, Zigbee, Home Plug, and then kind of our three Tier 1 standards bodies are IEC, IETF, and IEEE. This is, some of you are probably familiar with UCA. It was formed in, I'm trying to remember, was it 2000s? Something like that, or a little bit before that. Really as a users group for 61850. But it has since evolved, and there's a subcommittee, an Open Smart Grid subcommittee, which has 10 utilities sitting on it, and I'm chairing that group, and we represent 27% of the U.S. meters. And those 10 utilities are fundamentally the utilities that are highly engaged in deploying technology or have labs and are contributing and working in standards. We've got a group that focuses on security, which is Utilisec, which has produced documents jointly with DOE on smart grid security, and are actually some of the documents listed in the work being done right now. There's a communications group looking at how is the overall networking requirements being developed. There's Open HAN, and this is we also moved the requirements piece of the work that LBNL was doing into this forum to put it into an open standards process. And there was a set of work done a couple years ago around AMI requirements. And then there's a very active focus right now on Smart Grid Enterprise and mapping a reference model for 61968 and 70 in the IEC, and making sure that we map requirements around all of these different applications to that enterprise-based architecture. And this is a place where if you want to get involved, you can. I think individual membership's like $250, but there's a lot of experts across industry. All of the information is open. You can get it on the web, and you can get on the calls, and you're actually working with peers in industry that are very focused on solving these specific problems. So I'm going to get a little bit into what are we doing specifically at PG&E. So what type of work are we doing? So I think this goes back to my comment that the smart grid is a journey. It's not an end state. And I think we've really migrated from, a utility in the past may have gone out to multiple vendors, gone out with a request for proposal, and solicited bids to go build, let's say, a generation plant or some fairly mature technology. One company wins that bid, and we go build it. Well, the majority of the things we're deploying now have never been deployed before. They have never been made to work the first time. So our whole philosophy about how we deal with those is very different. So we work in standards to help define and steer what those technologies are, but we also are, historically PG&E had a lot of research and development activity, but that waned over time. We're bringing all that back to create test facilities and go into a pilot program. And the idea is you go through this standards testing and pilots at very low cost and take the risk out before you actually scale any of these technologies. We're in different phases of building. This is what my labs look like. I've got a group in San Luis that is really kind of a networking and application experts group. So we've built a whole back end, and what we don't build at the back end, we build simulators around outside of our operational firewall. So I can go break things. I can load code overnight. If for those of you that have worked at a utility, trying to change code in an operational network, can take weeks, and rightly so to some extent, because that system affects the customer. So you can't put at risk your customer. So we're actually building this whole structure of network components outside the firewall. In San Ramon, I've got a whole facility which is kind of the router out. So it's meters, it's home area networking, it's demand response devices, it's SmartGrid devices, it's anything you think of that can get plugged into the network, and we're putting all that together in a lab to build it. And then we have a facility that exists and has existed for quite a while in San Ramon as well that was traditionally very power engineering research and development and testing centric. Well, we're networking all of that. So we're creating this distributed lab which implements to a large scale a representation of a smart grid outside the firewall, and we can basically go try things and blow things up without getting into too much trouble. And these are just some pictures. So this is the labs I have down in San Luis, which has a bunch of traditional servers and systems and some benches to work on some things, and we've got a bunch of hand stuff we're playing with there. This is the lab in San Ramon, which is very communication centric, so very traditional communications gear. We've got meter boards up on the wall, we've got an RF shield room, things like that. And this is our existing facility down in San Ramon, which we're networking all of these different elements. We have 5 or 6 miles of 230 kV transmission line. We have a whole substation off the grid. We've got a facility where we've done a bunch of photovoltaic and inverter feeding energy back into the grid. We've got a vehicle lab. We've got appliance lab. So we've got all of the power stuff, and we're adding the networking component so we can build this distributed smart grid lab and pilot and test all this stuff before we actually put it out. So key takeaways, I always like to pop this at the end, right? But standards are the primary critical component necessary to build an interoperable smart grid. I mean, I think if you had to pick the one thing that it was fundamentally dependent on, you could probably say that. And in my comments on the open process, right? So these things can't get done in a back room. They have to get done in an open process. You have to build consensus across the country. That doesn't mean everybody agrees, but it means everybody knows the process, and they agree to the process. So even if they don't get what they want out of the process, they move forward. Certification cannot be achieved without standards, but certification is probably even more critical than standards. Because without certification, you really won't have interoperability. And then finally, I go back and forth between tremendously excited and tremendously overwhelmed. Those are my two modes, and it's almost more overwhelmed now than it is the excitement. But I really see, from an academic point of view, the creation of a whole new technical discipline, which is really the merging of power engineering and communications engineering into stable systems, closed-loop system and engineering. And you can't answer the question if you just have one of those disciplines. You actually have to marry both together. Just the fact that we don't have a open national type of an effort on a simulation platform that does this, right? We have all sorts of elements. We have NS3. We've got a bunch of different power simulation tools. But one of the things I kind of on my list I'd really love to see is some type of an open source common place where all of the different academic and research facilities are working to develop a simulation platform with abstraction layers so modules can be plugged together. But I just think there's just a tremendous amount of fun. You pick your area, right? And this is going to be the top of industry over the next 20 years, right? 20, 30 years. You're going to have anybody that's working in this space will have tremendous opportunity and more problems than you can ever solve. So I'm excited when I stop being overwhelmed. So
Very nice.
That's it.
tours of the standard main line?
Pardon?
You do tours of the
I do, yeah.
I just asked Chris if there's a tour available of the nice lab you saw there. I think some of Dick White's students and I have been there. So, but questions from the floor. I think you just beat it with your hand up first, Gary.
I was just wondering, are you starting to see an industry consensus around the need for distributed decision-making and intelligence?
I think those that are, I would say yes for those that are working on the problems. It almost becomes a no-brainer. I think there's a lot of opinions that are maybe based on on older ways of doing things or people that haven't really thought about the problems or looked at the amount of data flows. So, I mean, yes and no. Yes, sir.
On the plus side, the smart grid is going to promote efficiency and reliability. On the minus side, you've got a lot of research costs and implementation costs that have to be amortized. And I'm wondering, what's going to be the bottom line effect on the home, on the residential energy consumer? If everything else were held equal, would one expect the smart grid to end up costing them money 10 years from now, or would they expect to be saving money?
Yeah, I mean, so unless you do a business model, you can't quantify the answer. But in general, the way I see it is the imperative that we're running out of energy at peak. If, let's say, we didn't do anything, what would happen is the price would just excessively rise, right? Or even some type of rationing or something, right? Who knows, right? But we have a scarce resource. So the only solution is to manage that resource. So I think the alternative is, you would have to go down that path. So we really have no choice, right? I think you have to do it. And then the target is to drive better efficiency, better, lower cost, better information to the consumer so they can make wise decisions. I mean, right now, I don't know what my energy bill is until I get it, right? And if I could look real time in the refrigerator and see, or on my web page or TV screen and see that, hey, my bill is projected to be X, I better start managing it a little bit better. I think just, take away all of this distributed networking and optimization, just that information, I think will have a tremendous amount of value to the customer.
Hi, I'm actually wondering if you can say a little bit more about stability. You had a slide up about it, and I can see how a much more adaptive system is nice, but you're also describing a system which is going to react much more rapidly with much thinner margins. So it would seem like the possibility for runaway kind of reactions and failures.
Yeah, well, that's the exact thing, right? You have all of these let's say, fairly non-deterministic closed loop state equations, and if the delay is, you can have something coming up and something else coming down, and if the signal gets there when it's changed its direction, you could conceivably, let's say, have a signal continuing to ramp a power source up when it really should be coming down, and those create unstable modes. So the whole comment is that you have to be able to design the system understanding all of the latencies and requirements in the communication path as well as the power engineering path to make sure you don't create one of those. And then you have to have mechanisms to mitigate such events when they happen. So how do you open the loop, right? How do you open the loop? And you probably need 2 or 3 mitigation paths so your reliability is very high.
Next question? Yeah. There's a question here. No, sorry. You have a question. You did one already. Let's get him. You got it.
Okay. I think I would add another bullet to that slide. After standard and certification, I would add application development, because we're developing a platform here that just begs for all kinds of applications like an iPhone.
Yeah.
And so only more complicated.
Yeah, I mean, I guess that's a great comment, right? And I guess I kind of take that as a given. I almost take that as a given that it will happen, because in the standards we're defining common interfaces. We're not defining the applications, but we're defining kind of like a common API or a common set of messages to those, and that empowers industry to develop those applications and companies to compete on size, color, shapes, sexiness of the device, whatever.
Yeah, I was just thinking about jobs.
Yeah.
A lot of jobs.
Yeah, that's true. Good point.
Hi.
Yes, sir.
I just had another question. So you talked a bunch about the information aspect of this, installing wireless meters and all that stuff. Since the goal is sort of to reduce the peak demand, what are the actual control methods for peak shifting? Are you going to rely on consumer behavior, demand response programs, energy storage, et cetera?
All of the above. I think that all of those add up. And when I think about this, I almost think about it as it's not really a two-step process. It's a bunch of things layered in time. But you really have to get the transport mechanisms beat out first. So I'm going to do all these applications. But I can't do them until I get the transport done. So I get the transport done, and then you do the applications. But I don't mean that to say we stop and we get all the transport done and then do all the applications. We'll work. For instance, now we're doing our AMI system. That gives us transport to our meters. We can do web-based hourly data to our customers now. We'll add the transport to the home area network within the next few years. That'll allow us to put certain devices in the home. Certain devices like displays and thermostats will come first, vehicle integration fairly soon after, maybe photovoltaics later. So all of these will layer on over time, empowering different applications to drive different methods, whether it's demand response or peak shifting or just pure energy efficiency.
Will this standards process lead to a worldwide uniform set of standards, or will there be different standards for Europe and, say, India?
Yeah, another great question, right? And we have a history of global fragmentation of standards. But I think we want to minimize the fragmentation, and you do that by, the international standings being your top-tier standards, IEEE, IEC, and IETF are three very good ones. I don't know how it's going to fall out, but I think if we can actually pull this together and do it, it'll set a model that will be hard to not align with. Although, the systems are different in other parts of the world, right? We have 6 to 7 homes per transformer. Europe has 50. Japan has 100. So what is logical for those systems and the type of architectures is not necessarily what's logical for our North American architectures.
Yeah, there was kind of an unstated assumption in your talk that there would be one smart grid in your service area and you would own it. Is that basically the only kind of possibility, or could it, I go into business to have built the alternative smart grid to Berkeley, just like Comcast went into business to compete with AT&T?
Yeah, well, I don't think there is any one smart grid. Smart grid is just a system of interfaces and standards that can plug together to offer a whole bunch of different services and businesses. So I think the answer to your question is yes, there are multiple opportunities, right? We as a utility will have elements we own, and we'll have defined interfaces, and there'll be protocols to communicate over those interfaces, which certainly could empower and share information for third-party services and businesses.
Hi. I had two quick questions. The first is, what is your perspective on the evolution of, say, the security technology and the sort of regulatory policy evolution? Because it's possible that one may make the other, basically preempt the other at some level.
Well, so I'm not an expert on politics, right? But I certainly see a lot of discussions, and if you're on any of the mailers, you see them in the House right now debating security and regulation. I guess the simple answer is security is going to be a driver for that regulation, and then eventually some regulation will be defined to ensure that everybody follows the appropriate security.
Okay. The sort of slightly disjoint question is, in the current situation, do you sort of see the control loops for the power, including the SCADA-related control loops?
Do I see that?
I mean, do you think there's sort of enough of a preventive sort of mitigation sort of built in, to use the word that you were using, in order to prevent?
There certainly is a lot of preventive stuff now, right? But you're going to, as you add more complex interfaces and communication loops, you'll create more problems. There will be challenges. There will be design issues that have to resolve. And I guess what I'm trying to say is that as we go through this process and you design systems, you have to follow good disciplined systems engineering and making sure you mitigate those issues.
So specifically, there's this YouTube video where people were hired to blow up a transformer, right? So do you think that's sort of a real scenario that's feasible at the moment, or is that sort of an extreme?
Well, I think anybody can. You can create anything you want on a video, right? I think there are a good system will design the probability for such instances to be very, very small. And you'll do it through evolution of the design, and you'll do it through multiple mitigation mechanisms.
It looks like how you described the smart grid as sort of an existing communication structure overlaid on an existing energy distribution structure. So is there really a missing technology piece, or is it more sort of systems integration? Is there a part that you can identify that hasn't been invented yet?
Yeah, well, that's a good question, right? And I don't really see it as all existing. I mean, I think that's the vision of the domains and how the interfaces will map together. I think all the technologies exist. I think in certain, so if you create that whole interoperable framework and you kind of draw stacks and interfaces, right? There are certain areas in those stacks that have clearly defined standards, right? And some of those are on the list. They're there, everybody's using them, they agree. But there certainly are gaps. Like AMI, for instance, is a good example. We're deploying an AMI system. It's an IPv6 system, but within the transport mechanism, certain areas of that are still proprietary. And there's multiple vendors with different instantiations of AMI systems. So over time, there'll be a harmonization and a rationalization of those standards. I think did that answer your question?
So I have heard you already have some sizable or middle-sized, let's see, testbed in somewhere Central Valley. What's the status for that, and what feedback from that?
It was the question.
Yeah, smart grid, kind of smart grid, testbed. Is it true?
Does PG&E have a testbed?
Yeah.
The slides I showed up there that talk about the lab, so we've got lots of little things that we're doing from the lab, right? Do we have anything large like what Boulder is doing, for instance? No, nothing like that. In fact, what we will do is we will do things in smaller scale, vet them out, and then scale them as we prove the features and the functionality.
I see. In that sense, let's see. I'm sure you need some sizable testbed before fully implemented that. Mm-hmm. So when it may happen?
I don't have a definitive date for you, but certainly over the next 2 to 3 years, we'll be evolving different pilots, and we won't do it all. I don't think the right answer is to do it all at once. You don't say it goes back to you can't define a smart grid. So we're doing our AMI now. I mean, that's going to scale over the next 3 years. That's a big piece of it. Home area networking, we'll do the same way. We'll do very small pilots. And then as we prove out features, we'll expand it and scale. And then we'll also layer more features on in time. The same philosophy will probably map to how we do transmission and distribution, however this stuff gets defined. So a gradual layering of technologies and elements over time.
Last couple of questions, I think.
Chris, in answer to your you answered the question about new technology needed on what you might call the physics side. I agree with what you said up to a point. I think, though, if we aren't careful, what we may be doing is creating an inverse Frankenstein monster in which instead of putting an abnormal brain into a hulking body, we're going to be putting an extraordinary brain into a very puny body. So I think without new technology, we can't really make the smart grid work. And I think areas of power electronics, advanced materials for higher current flows and higher temperatures, perhaps higher voltages, or maybe going the other direction, advanced modeling techniques, advancst mathematics, I think all those are going to be needed if we're going to make it happen.
Well, I absolutely agree with it, and I think maybe the context of my prior answer was that do enough technologies exist today where we can move forward with this? Yes. But is there great opportunity for innovation in the future on this? Absolutely, right? I mean, there's huge opportunity.
2 more final questions, one from the gentleman there, and then the lady with her hand up at the back. So carry on.
So it seems like we're going to want to have many or multiple players involved in developing a smart grid in the U.S. as well as abroad. And I wanted to get your opinion on the role that startup companies can play in that process, because especially with like large utilities where they already have research labs, I was just kind of curious to get your view on the role that outside companies can play in that process.
So number one, our lab is very small relative to the amount of work and things I could be working on. So I'm actually very keen to do joint projects, to support internships, to the extent I can. And we do that. I'm open to that with academia as well as and we have industry partners where we are doing that. So our research labs in utilities are just a small fraction of what is necessary, and I believe the way we solve this is by pooling our resources and working as partners. Right?
So last question, and then we'll break for a smaller discussion. If people have more questions, please come up to the front afterwards. And our last public question.
It seems the smart grid will provide the opportunity to all of the customer the real-time price. So since the real-time price will trending, that will make the average energy cost lower, right? And if that, will the flat rate will reduce for maybe some of the customers still keep on the flat rates?
Yeah, so I'm just a technology guy. I'm not a policy guy, right? But what I see happening is, eventually we're going to get to a place where everything is real-time priced. It's probably priced based on, locally where you are and what the cost of energy is. And I think the important thing is to have systems so that at the customer side, you can react to that price wisely. Right? So, and then the idea would be that net your energy is lower, your energy cost is lower because you're choosing to be efficient with how you use energy. And the systems we're creating supply you with the information that allows you to make those choices.
I think that's a fabulous way to end the seminar with that long-term optimistic vision. Chris, Thank you so much.
Thank you. Thank you, everybody.